The daily problem of the Leetcode for today is count good number. So, so here it is explained what is a good number. So let me give a brief overview. So good number is a number where the elements at even place are even and that of odd place is prime number. So here it is given that a digit string is good if the digit at zero index at even index are even and the digit at odd index are prime. So the prime numbers could be 2, 3, 5, 7. So there are particularly four prime numbers. And here is a case scenario that takes 2582. So giving it Hoy's score. So the index at even places are 0 and 2. That are uh, 2582. The 0, 1, 2, 3 are the index of the number. The element at index 0 is 2. Index at 1 is 5. That is a prime number. Index at 2 is 8. That is even number. And again at 3 is 2. That is a prime number. So we can say it is a good number. So we have to return the number of good numbers that are formed using that number of digits. Suppose here is given n equals to 1. So the number of digits possible with n equals to 1 are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So if n is equals to 1, so it will be at 0 index. So as per being it a good number, it should be even. So the even numbers are given 0, 2, 4, 6, 8. So the number of good numbers possible with n equals to 1 is 5. Then again see other example for n equals to 4. N equals to 4, that means the number of digits are there 4. So it could end with zeros. That means it could have leading digits 0. As it has already mentioned here, a digit string is a string consisting of digits 0 through 9 that may contains leading zeros. So this should be kept in mind. So n is equals to 4. So the index will be 0, 1, 2, 3. The elements at index 0 and 3, 0 and 2 will be even, and elements at 1 and 3 will be odd. Let me show you an example. Suppose the number n is equals to 4. So the number formed will be 1010. I am telling the possible numbers. It could be 2020, 2, 3, 4, 5. So let's take example of these three. So for the first number to be good, uh, let's check at index 0, that is 1. That is surely not even, so it is not a good number. Taking 2020, the element at index 0 is 2. So taking for 2, it's even. But when we proceed to index 1, that it should be prime, but it's 0, so it can't be true. Uh, but suppose we take here 1, okay? 1, or suppose we take 3. So 3 is a prime number. Then again for index 3, it's 0, but it's given it should be prime. So 0 is not prime. But let's consider this statement. A digit string is a string consisting of zeros to 9 that may contains leading zeros. So this is the possible number could that could be a good number. So using the four-digit number, there are 400 good numbers. So let's go for the main idea. Okay, okay. So suppose we are given n is equals to 5. So what could be the possible index? That is 0, 1, 2, 2, 3, and 4. These are the possible index, and here the even index are 0, 2, and 4. So what can we say? There are three even numbers, and how we find it? So it could be find using n into n plus 1 by 2. So suppose if there are given n numbers, so number of even index elements will be n into n plus 1 by 2. Similarly, for the odd, there are 1 and 3 that are n by 2. So it will be give the minimum possible number according to it. So here is 5. So their number of odd index will be 2. Suppose we take example 6, so 6 will be 3, 3. For 7, it will be 0, 1, 2, 3, 4, 5, and 6. So as per the formula, let's check the even number. So 7 into 7 plus 1 by 2. So it will be 7 into 8 by 2. So what will be the number? For 28. So there will be 28 even index. 28 even index. So let me correct it. Sorry. The number of even numbers are n plus 1 by 2. So here n is 7. So the number of even digits will be n plus 1 by 2. That is 8 by 2. That is equals to 4. Sorry for my mistake. And number of odd numbers will be n by 2, that is equals to 7 by 2, that will lead to 3. So there are 3 odd index and there are 4 even index. So what could be the elements at even index? Elements at even index could be 0, 2, 4, 6 or 8. And at odd index it could be 2, 3, 5, 7. So number of possible numbers that could go at even place are 5 and that could go for odd place are 4. So let's see here how will we count a good number. So we will take elements at even place that we will find using n plus 1 by 2, and for the odd place it will be n by 2. So to calculate the power, so here what we can write? We can write this as 5 to the power. What is uh, 5 possible numbers? There are 5 possible numbers that could go at even place, comma. What are the number of even index? Into, so it will be power. And for the odd index, it will be power of 4, comma, number of odd index. So keep it in mind. We should take it long, as it the value might exceed. So C450, it is such a great number. Suppose we are given n equals to 100 or we are given n equals to 1000. So for that, we have to keep in mind that it might not overflow. So for that, we use long. So here we saw we calculated the number of even numbers, we calculated the number of odd numbers, and to calculate the total number of good numbers, we have to calculate the power of 5, comma even, where 5 is the number of possible numbers and even is the number of even index, into power of 4, comma odd, where 4 is the number of elements that go at the odd position, comma number of odd position. And we have done modulo that I have defined over here, where mod is equals to L 9 plus 7. That is a constant used to take modulo to avoid integer overflow. So now the main, it was the main body of our program, that was count good numbers. And to calculate the power, I have defined the function over here, where I have took the base and the exponent. And for the result, I have initialized with 1. So if the exponent is great, the base condition, what is the base condition? That the exponent will be 0. So when the exponent will be 0, we know that any number to the power 0 will lead to the result 1. That's why I have put the result one over here. That is the base condition and the default condition. So while exponent is greater than 0, if the exponent is not even, then it will lead to the result equals to result into base modulo mod that I have defined over here to uh, avoid the integer overflow. Then for the remaining part where the exponent is even, base is equals to base into base in modulo mod, and the exponent is decremented by 2, so that it could be decremented and will lead to 1, and then we return our result. So I hope you understand. So let's first run the code. I have already run the learn, so let's run the code. So all the test cases has passed, and let's submit it. So keep in mind, it will give a time complexity of Vigo of log n. And talking about the space complexity, we have not used any extra array or vector to store the result. So the space complexity will be 1. And the space complexity, time complexity will come due to the power. So that's all. Thank you. And if you have any question, then do comment down below. I will try to rectify it.